This is the final worked example for the gravitational potential energy lesson, and this one's a bit higher demand. The idea is that they step up in demand, and this one brings together a few different elements all together into one question. So we're going to combine some of the things we've been talking about so far. So here we've got a carriage of a roller coaster approaching a slope. It's got a certain amount of kinetic energy, 25 kilojoules at the bottom, and it uses that kinetic energy to get up to a certain height. So the energy transfer that's happening is the kinetic energy is transferring into gravitational potential energy, but along the way it's probably going to lose some to the frictional forces as well, so it's probably going to lose some to heat. So let's have a look at the first thing we're asked. Show that the potential energy gained by the carriage is 19 kilojoules. Well, the first thing we know is that it's got up to a certain height and it has a certain mass, so we know that we can work out the gravitational potential energy using the formula we've used many times before. G.P.E is mass times g times by the change in height. So in this question, mass is 500 and we use our g as 9.81 as usual. With the change in height, it's gone up by 3.9 meters. We don't need to consider the distance up the slope at this stage because we're doing work against gravity, and gravity is acting vertically downwards, which is in the same plane as the distance we've travelled. So here, if we work out this using a calculator, then we'd get something like 19,129.5, which thankfully for us gives us somewhere near what we're aiming for, which is about 19 kilojoules. Yeah, 19,000 is going to be 19 kilojoules. So let's move on to the second part, where we're calculating the work done against the resistive forces. Well, what you might have noticed is that the kinetic energy at the beginning was 25 kilojoules. But we've only gained a G.P.E of 19 kilojoules. So where has the rest of that energy gone? Well, the rest of it's gone into doing work against the frictional forces. The work done by friction is going to be the difference between the two. And that's where our energy's been lost to. So 25 minus 19, which is going to give us 6 kilojoules of wasted energy, or work done against friction. Now we have to combine this in the last question, because the last question asks us to calculate the resistive force acting against the carriage as it moves up the slope. So not only do we need to know the work done by friction, but we need to know what the force actually was in the first place, or the average force. Well, let's think first of all, the force is acting down the slope, and we'll call the force F, and the distance travelled in the same plane as that force is the distance x here. So we can use the work done equation just using this amount of energy here. We know that that's the amount of energy that it went into the frictional force. That's the force, that's the distance. We can use work done, this is part 3. Work done is the average force F times by the distance x. But we've got a problem. We don't actually know what that distance is, but we can work it out using trigonometry, because we've got the opposite of the triangle and we've got the angle. So let's first of all work out what we think x is going to be. We need to use trigonometry using sine. So sine of the angle 30 is going to be the opposite over the hypotenuse, SOHCAHTOA. So the opposite is 3.9. The hypotenuse is our angle x. So rearranging this for x, we end up with x is equal to 3.9 divided by sine of 30. Now that gives us, because sine of 30 is 0.5, that gives us 7.8 meters. So our x here is 7.8 meters. Now that's good, because now we've got an equation where we've got the work done, that's 6 kilojoules, we've got the distance x, and we're trying to find the force F. So all we need to do at this point, just move this out of the way, is rearrange for F. So rearranging this for F, the X is going to come under here. We're going to get work done divided by X, which is going back into joules for this point because we need to get our force in newtons. So 6 kilojoules is going to be 6,000 joules divided by 7.8 meters, which equals 769 newtons.